at question number 4. As I said, I've never looked at this question, okay? There's so many different trig identities. Okay, so what I've done is I have copied my tools, my substitution tools, because these are the things that are going to help me. Okay, and I'm just going to put it to the side. So that's one technique to have them that you can actually look at them to see what you need. Now, when I look at left side, right side here, both of them have brackets. The difference being, I think the left side, because it has a reciprocal here, I think that I would choose this side. Okay, so that's what I'm going to do, and I'll see how I make out with it. I might make out fine, and I might not. So let's go and we'll do it in blue. Okay, so as I said, this is the process I would have to do. So I'm looking at this, I'm thinking the left side is the worst option, and this is going to be my reasons. And again, all the way down. And I'm going to start with this. Now, there's a few different ways that I could do this one. I'm looking that when I see this, I'm thinking, oh, I'm wondering if I should do FOIL before I do anything else. And, or should I substitute the tan with the quotient identity? Or should I get rid of this reciprocal function? So it's at this point that I make a decision, okay, whether it's good or bad. I could find, I could do, because I'm thinking 2 steps ahead, I could change this and then that would make this a fraction, and then I could find a common denominator between the two. And the same thing over here. My only concern about that is maybe I don't need to find a common denominator. I'm not sure. So again, it's totally up to you what you think that you should do, or we can actually put it through. I think that what I'm going to do is I'm going to do my substitutions first. So I think that I will get rid of the tan and the cotangent. The reason being is on the right side there is no tans or cotangents. So I know somewhere along the line I have to do a substitution. So to me, that's what I think I'm going to do. So let's see what we end up with. So we have a sine x minus the quotient identity, which would be sine x over cos x. And this one would be cos x, and this one would be 1 over tan x. Now if I do this, the reason I could do that is I did, first of all, I did the quotient ID, and I did the other substitution in the other bracket, and that was the reciprocal ID. All right, so when I look at this, the first bracket, there's not too much more I can do there. The second bracket, I could do something to it. And I think what we'll do is, I'm thinking, you can tell that my brain is just turning. Can you see it turning? No, I can't either. So I'm going to leave that one alone for a second. And the reason being is I'm going to change this tan, because we don't want any tan. I'm going to change that to, that's the same as 1 over sine x cos x. Okay, what all I did there again was the quotient identity. And I'm going to straighten this up. I'm going to leave this alone, even though I'm thinking in my head, I'm going to make a common denominator there. I know it. I know it. Okay, so because it's a proof, I'm only supposed to do really one, oops, I forgot an N there, one thing at a time, so that there's no doubt in someone else's mind what you did. Okay, so this would be cos x minus, okay, and this is going to end up flipping it around, And the reason you can do that is you're actually dividing with fractions because you invert and multiply. Divide fractions. Now when I look at it, yeah, eventually I will do FOIL, I think, but I'm not sure. So I'm going to go back up and I'm going to look to see, well, I need a sine x minus 1 and a cos x minus 1. So I think I'm still going to work with what I have, and I'm going to find a common denominator. So this is over 1. So my common denominator is going to be cos x. By the way, this might not even work. If it doesn't work, I won't delete the video. I'll just show you what would you do if it doesn't work. So this then becomes sine, just hold on, I'm thinking. Or should I do my distributive at this point? Because I'm thinking some of those might cancel. Oh, let's do that distributive. We know that eventually along the line we probably will do that. Yeah, so that's one nice thing, that you can change your mind. Oops, don't want that thick. It'll take us a million pages. So I think I will distribute this. So I am going to go this times this. So that would be sine x cos x. Then when I multiply this one by this one, the signs are going to cross out, and I'm going to be left with minus cos x. Okay, so we understand that because it'll be sine x times this. So the sine is on the top, it'll cancel with the bottom. Then I'm going to take this term, and when I multiply it by cos x, you can see the cos x's are going to cancel out. So I'm going to be left with a minus sine x. And then what happens here, when I multiply this by this, the sines are going to cancel out, and the coses are going to cancel out. And my answer is going to be plus 1, because I have a negative times a negative. So all we did there is FOIL. So you can put FOIL. And then I look at this and I think, how on earth am I going to get it to turn to this? Well, you know what? I think if I factor by grouping, it would work. You're saying, what? Yes, let's try factoring by grouping maybe. What would happen if I took these two together and I factored out a cos x? If I factor out a cos x, I'm going to be left with a sine x minus 1. Okay, and I still have minus sine x plus 1. I keep on forgetting that n. So what I do there, I just factored. Now, as I said, I'm not quite sure, so you might not want to write down everything. Let's take a look. Well, I have now the sine x minus 1. But my problem is this part here. What if I changed that 1 to the Pythagorean identity? And you're saying, really? Yes, really. Okay, so that's kind of what I want there. So that would be the same as sine x. Oops, I don't know why it does that. Sine x plus, it would be sine squared, sorry, I better do x, sorry. Sine squared x plus cos squared x. Okay, and that was the Pyth identity. Now, as I said, we like this, but now when I look at this, well, I could factor something out of that, I suppose. And you're saying, really, Mrs. Bradian? I really don't think I like this. And should I take out a negative sine x or a positive sine x? I'm going to take out a positive sign. And when I do that, I'm left with -1 minus sine x squared, and just minus x plus cos squared x. And then I would stare at it and decide, what do I need to do now? Oops, better change that to an x. So now when I look at this, I'm thinking, okay, I really don't know what I need to do here. So what I'm going to do is I'm going to look backwards to see, and this is the process that even I have to do. I made some decisions along the way. Okay, some of the decisions I made, remember, was here. I could have distributed through. We chose not to. The next one was I could have found a common denominator and then distributed through. And my other decision was, what if I factor by grouping? And what I'm going to do is I'm going to look back at what I had before I factored by grouping. Okay, so this is the process that you actually go through. What happens if I factor it a different way? I chose these two here to factor because they both had a cos theta in them. But what would happen if I took this first term and the sine x together and factored out a sine? So that would be the first thing that I would do. So what I'm going to do is I'm just going to put this around here. Okay, as I said, I want to go back through my process to see, okay, what decisions did I make? What would happen if I chose a different decision at that point? Would that have helped me more? Now I'm just going back to the most recent decision to see what's going to happen. So this is the one that I'm going to take, and I'm just going to clone all of that and bring it here for a second. Okay, other than my equal sign didn't come. Now I'm not going to erase this. Okay, if this wasn't my proof, I would probably go something like this and I put omit, unless it was obviously an assignment I was handing in, which you eventually will do. So let's go back and hold on, pen, where are you? Here you are. And I'll switch it to green, just so you can see that this is the point where we went to try something else. So I'm going to put this one and what did I say, the sine one together. So I'm going to factor out a sine, and when I do that out of those two terms, sine x, this term becomes cos x, and this term would become -1. And then what I'm left with is cos x plus 1. Okay, now the reason I just did there is that was still factoring. Now, I do have on the other side that I want to have is a cos x minus 1, but I also need to have a sine x minus 1. So actually what I am going to do, because I'm factoring by grouping, is I'm going to take these two last terms and I'm going to factor out a -1 out of them. Now you can see why factoring is so, so important, because it comes in handy even on this stuff that you just love. So when I factor out a -1, I would have a positive cos x and a -1. So again, I'm factoring. You can see that I have two brackets that are the same, so I'm factoring them out. And when I factor it out of this one, I'm left with sine x. When I factor it out of the last bit, I'm left with a -1. And again, that's factoring, and amazing. Wow, look, it does equal the right side. Okay, so all we need to do is a therefore statement. So this just gave you an idea of what really is involved when you're actually problem solving these. And did it take us almost 15 minutes? Yes, it did.